Hello everyone. In this video, I just would like to share to you the simple steps to do exploratory factor analysis, especially using principal components in the SPSS. So let's find out. Alright, so first of all, that you see in the screen here that I collect the items to develop the instruments. So the skill development here is about leadership behavior. So based on literature review, that I only found 24 items that represent leadership behavior. This is the result of my content analysis. But in order to determine or examine the konstruk validity, then I need to do the exploratory factor analysis. So I want to know how many factors or components that represent the konstruk of leadership behavior, right? So I'm gonna put all the items in the SPSS. So can we open SPSS here, so you can see 24 items is already there, and you can see the sample size that I have 240 samples. So it's quite a lot because I use item response ratio based on anomaly. You can see later that I'm gonna show you the literatures or the literature support why I choose this one. Well, actually, basically the anomaly is the rule of thumb to do the EFA factor analysis, but you can use any other literatures to support your argument, right? So here 240 samples. So what we're gonna do first, in order to do the EFA, basically we need to test the assumptions first, right? So what we're gonna do right now is just to click analyze, and then dimension reductions, and then click factor, and then you just click shift for all items, and then just click here to put all the items. And from the descriptives, want to know either missing items in the scale. Well, and then after that I'm gonna check the coefficients, correlation coefficients, because I want to know whether any overlapping items and determinants, maybe not, but it depends on you. And then KMU and Bartlett test, of course this is important, whether that your sample size is quite good enough to do the factor analysis. And for the extractions here, there are many methods here: principal components, unweighted, generalized, maximum likelihood, principal axis, alpha, or image is all up to you. You can choose, but the favorite one, people most likely choose principal component. And what we like to see here, well, extracts, of course, you're gonna see from the eigenvalue. I don't want to do, how to say, just click here, because I don't want to decide by myself, like say like I'm gonna choose like 4 components. No, I don't want to do that. So I just let the SPSS to do it for me based on the eigenvalue greater than 1, right? And for display, yeah, I'm gonna see the script plot, whether the result, the SPSS, really fit with the script plot, right? So click continue. And then for the rotations, you can see here the orthogonal and the oblique. Well, most likely people use Varimax, but you can see any other, how to say, methods is all up to you. But for me right now, I'm gonna choose Varimax rotation because I want to know directly that the factors are uncorrelated, and then there are separations in any factors in the SPSS. Alright, so click continue. For the scores, I don't want to set as variables, so I just leave it at default. And then for the options, exclude case listwise is all up to you. You can exclude the cases here or not, but I just leave it for the default for the missing values here. And for the coefficient display, right, I want to sort by size, so I want to know which one that has bigger factor loading that come first. And for the super small coefficients, well, you can see many choices here, but for me, some literature mention it should be like 0 0.2 or 0.3, 0.4, 0.5, but the higher the better. But I make it here 0.40 for the more important coefficients in the factor loadings. So I make decision based on 0.40. But if you have so many items, you can choose higher. But if you just have less items, you can use lower. Well, it depends on you, based on your rationale, right? All right, so it's already there, so we can click OK here, so you can see what is the output. So from the descriptive statistics, right, so you can see is there any missing items. So from 240, all 240, all right, so there are no missing items here. And for the correlations, of course, we would like to see that in each variable they have significant correlations perfectly 1 1 1, but you can see in each item among items if there are any overlapping, because we don't want to see, for example, 0.9 or something, because it's going to be overlapping. Well, it's quite good for me. For the cameo, so Kaiser-Meyer Olkin measure sampling adequacy, you can see his 0.8. So some literature mentions we need to keep the samples if the cutoff point is 0.8, but the minimum cutoff point, some literature mentioned, is 0.6. So you can choose which literature that you want to choose, right? And for the valid test, yeah, it should be significant, right? So it means sample is sufficient to do the factor analysis. And another assumption that you need to see is commonalities. So you can see here the cutoff point for commonalities. Well, basically, some literatures mention it should be like 0.4. You need to keep it that way. And some said it's 0.5. And here there is a one item 0.4. So I'm gonna use the literature that use 0.4 for the commonalities. But if you really strict with the 0.5, it's okay. So you can just delete this item and then you can retest again for the assumptions, right? And for the total variance, you can see from the first order of the EFA. So the machine, the SPSS decided for me 5 components here. So explain 64% of the total variance. Is quite good, because in the social science, at least 60% is quite good enough to explain the total variance, right? And the script plot here, well, you can see here, actually 1, 2, 3 is quite okay to just decide to be 3 components, but because the fifth component here is quite up a little bit, so you can do another perspective here. You can choose 5 components, so 1, 2, 3, 4, 5 components. So script plot is in line with this table, right? So you can choose 5 components in there because it's going up a little bit here, but the other factors are quite low. Okay, here the unrotated component matrix, I don't want to see this, but you can do if you want to compare, right? If you want to choose this one, because the item exists in 2 components, in 2 factors, so you can choose which one that belong to one factor. So you can, there are some literatures mention that at least the difference between 2 components in one item at least 0.2, but you can choose any other literatures, anything you want, but you can decide based on the theory or the concepts whether that items belong to one component, or you can choose the highest one, because just only the simple way of thinking that the highest belong to one component, or you can choose the difference of 0.20, right? So up to you. But in the principal components, you can see here rotated component matrix, so they decided for you already here. So in the component 1, 2, 3, 4, 5, 6, 7 items already here, and then the component 2, 5 items, component 3, 4 items, component 4 4 items, component 5 4 items, right? So it's quite good. There are 5 components or five factors that represent the leadership behavior constructs. So we can retain to keep all the factors here, because at least in one component has 3 items. That's the minimum number to keep the one factors. But if you just only have 2, it's better to delete them, right? So there are literatures I'm going to show you after this. So I'm going to give these 5 items, but this is only the first stage of the how to say, the EFA, whether I need to just only use this results or not. You can see the next step. You can see the inter-item correlation, which is also important to decide whether the assumption for factor analysis is met already. So another step, I'm gonna choose analyze, and then I'm gonna use scale for the reliability analysis. So I'm gonna put all items here. So I'm gonna click reset first. So I'm gonna click all items and then move here. So I want to know inter-item correlations, right? So I'm gonna choose just 3 of these. So click OK. So for the Cronbach alpha 0.9, that's good. And item statistic, yes, it's the same. But here, the things that I would like to see here: corrected item, total correlations. I want to know whether any other item that less than 0.30. Most likely is quite good, but here one item 12 here, 0.26. Other one is all okay. So in this point, that you can decide whether you would like to delete it and then reanalyze, or you just keep it. So it depends on your literature that you want to use. But for me here, because I use 0.30, not 0.20, so I'm gonna delete this one. But if you want to see 0.20 only, if you want to keep 0.20, so you're gonna keep this item. So you can just use the result of the first analysis, right? But because I use 0.30, so I'm gonna delete this 12, right? So I'm gonna delete this one. So I'm going to see the so I'm gonna delete this item, and I'm gonna reanalyze again. So let's check. Okay, so I'm gonna check again. So you can see the here, so 23 items right now. You can see corrected item total correlations. So here 0.3 T1, and the others, there is no single item that less than 0.30. Okay, so it's good to go for 23 items at the moment, right? 23 items here. So I'm gonna do the second order of the EFA. So I'm gonna choose analyze again, dimension reduction, factors, and here is already there because item 12 is already deleted automatically. So it's all the same, but I don't want to keep any variate descriptives. And for coefficient is okay, so leave it that way. And here based on eigenvalue, okay, and using Varimax, okay, this one default, okay, and then suppressed by factor loading 0.4. Alright, so I'm gonna click OK. So you can see here for the correlation, nothing is okay for sin coefficients, and then cameo still in the 0.8, also okay, and then Bartlett test is significance. And then for commonalities, you can see there is no items that less than 0.5 here. Wow, that's good. So when I delete that item 12, so now there is no item, there is no commonalities that less than 0.5. And then for the total variance explained, this is still in the 60%, but here is 66%, so increased a little bit compared to the previous one. So, but still 5 components, right? And scree plot, I think is also the same, so I'm gonna keep like 5 components based on scree plot also. And here you can see the component matrix, but I'm gonna choose this one for the rotated component matrix here. Alright, so oh, it's interesting here. For 26 here, so appear into components 414 and 455. If you would like which one that you need to retain, well, basically, if you want to see, you can read each item, which components. You can read the items whether these items is really fit with this one or this one. So you can decide based on the conceptual items or based on the highest number here. It's all up to you. So basically we can decide whether it fits with the concepts, because it should be like you can feel the sense of the items, or you can just choose easily based on the number of statistics. So there is no argument, you just choose the highest one, that's it, right? Okay, so I'm gonna choose this one. I'm gonna choose this one, 0.4, right? I'm gonna choose this one. So here lucky still have 3 items, so I'm gonna keep this one too. And here 4 items, this one 4 items, gonna keep this one. So here 5 items, and then in the component 1 is 7 items. Well, is quite good. And the hardest part here is how to label the name each component, because you need to name it. Component 1, what is the name? Component 2, what is the label? 3, 4, 5, the same. So the 5 component represent the leadership behavior constructs, which explain the 66% of the total variance. So that's it. That's the result of the EFA that you need to report in your study. Now I'm gonna show you the literatures. Here, Cristobal said that the minimum acceptable item total correlations, this is inter-item correlations, right? So the cutoff point is 0.30. So this is the literatures. The decision that we make to keep the items here. Items were evaluated in relation to their association with a component. Items with weak associations were considered for deletion from the scale. Decisions were based on retaining component with eigenvalues greater than 1 and retaining item having associations more than or equal 0.4. So as I told you before, that I'm going to use 0.4 based on the F-list here. So you can see the literature support here. And the factor loading is classified based on their magnitude. So here, if you want to choose 0.3, it's okay, it's minimum consideration level. If you want to choose 0.40 is more important here. But if you want to choose more than 0.50 is practically significant. So the higher, the better. But there's actually many considerations. If you have so many items, you can choose 0.50. And items were considered to load on particular factor if the factor is 0.20 higher than is loading on the other factors. So it's based on Young plot here. And at least 3 strong and clean items are required to be a factor. So, and for the cameo here, 0.8 to be kept, but 0.6 is the possible cutoff values, because it means the sample size is not good enough to do the factor analysis. And for the commonalities I told you earlier, so between 0.25 or 0.4 have been suggested as acceptable cutoff value, with ideal commonalities being 0.7 or above. So in my example is 0.5. There is a 0.4, but after I deleted one item, there is no 0.4, but all is above 0.4. So it means it's quite okay, right? So here you can see the literature support that maybe you need. And for the sample size, here you can see the item to response ratios. I choose based on nullity here, 1 to 10. Alright, so 24 items, 240 samples. Right, so good enough. Alright, so maybe just that's all, guys. And the next steps, if you have any other samples, you can do the confirmatory factor analysis to confirm these factors, whether they have a good fit or not. Okay, but if you just only keep only for the EFA for now, it's also okay. Thank you very much for watching. Thank you very much.